All right, let's go ahead and go over this. So for problem number 1, it says a 3-colored rainbow has red, blue, and yellow. We're going to make a tree diagram to identify the sample space for the different ways that you can build the rainbow. So first of all, how many different outcomes should our sample space consist of? Jocelyn? 6. There should be 6 different outcomes that you have in that sample space. So the first thing that we're going to focus on is the first color, right? So when we're choosing our first color, how many options do we have to choose from? 3, right? Red, blue, and yellow. We have all 3 possible colors to be able to choose from. So I'm going to put down red, blue, and yellow. Those are all 3 possible outcomes that we have to be able to choose from. Then I move on to being able to choose my second color. So when I'm making my second choice, how many colors do I have to choose from then? How many? So if I choose red for my first color, how many are left to choose from? 2. I only have 2 colors to be able to choose from after I've chosen red. So if I choose red, my 2 options remaining are blue or yellow. If I choose blue, my 2 options are then red or yellow. If I choose yellow, my 2 options remaining are red or blue. Okay? Then I have to make my third color choice. So by that point, I only have 1 color remaining that I can choose from for each of them. So if I choose red and then I choose blue, the only color remaining would be yellow. If I choose red and then I choose yellow, the only color remaining would be blue. If I choose blue and then I choose red, the only color remaining is yellow. If I choose blue and then I choose yellow, I only have red remaining. If I choose yellow and then red, blue is remaining. If I choose yellow and then blue, red is remaining. So that tree diagram helps me to be able to build my sample space. And like we said before, the sample space is going to have a total of 6 options in it. So I could do the order of red, blue, yellow, red, yellow, blue, blue, red, yellow, blue, yellow, red, yellow, red, blue, yellow, blue, red. Those are the 6 different color options or orders that I could create with my tree diagram. Everybody clear? Okay, and then from there they might ask you a question of like, hey, what's the probability that red is going to be the first color? So how many times does red occur as the first color? 1/3, right? 2 out of the 6 times, so that would simplify to 1/3. The probability that red would be the first color and yellow would be the last color only happens 1 time out of all 6. Okay, so they could ask you different questions based off of those probabilities. All right, let's take a look at problem number 2. The probability that we're going to land on heads when we flip a coin and roll an even number when we're rolling the die. So if we split these up, let's focus on the first one, heads. What's the probability that it's going to land on heads? Emiliano? 1/2, right? So the probability that it's going to land on heads is 1 out of 2. Probability that we're going to land on heads is 1 out of 2. Then we're going to roll an even number on the die. So the probability of an even number. How many even numbers are on the die? 3 out of 6. And yes, I know that that simplifies to 1/2, but for right now, I'm going to leave it in its raw form because I'm just going to go ahead and multiply them. And remember, your calculator will simplify it for you. Use those calculators, okay? 1/2 times 3/6 is going to give you 1/4. So your final answer is 1/4 of the time you'll get heads and an even number. All right, let's take a look at problem number 3. The probability that we're going to roll a number that is greater than 1. How many numbers on the die are greater than 1? 5. Out of how many? 6. So the probability that a number is greater than 1 is 5 6. A vowel. Okay, remember vowels, we're talking about A, E, I, O, and U. So the probability of a vowel in the alphabet is what? 5 out of 26, because there are 26 letters in the alphabet. Then you're going to multiply them. When we multiply them, we're going to get what? Very good. 25 over 156. And then you're done. Any questions? All right. Let's go ahead, flip on over to page 16. We're going to talk about simulations. So when we talk about a simulation, sometimes in life there are events that happen that are probability events, and we use probability activities to simulate those real life situations. So a simulation, again, it's just an experiment that's designed to model the action of a real situation. So let's say it's date night, and you're trying to pick what you're going to go to. So are you going to go to the movies, or are you going to go out to eat? So how many options do we have? 2. Okay, we have 2 outcomes. What activity of chance do we know that has 2 outcomes? Think about it. What activities have we talked about that only have 2 choices? Jane? Flipping a coin. So this real world situation here has 2 outcomes. So a simulation, an activity that we can do with probability, is flip a coin. And honestly, that's what my husband and I do. If we can't decide on what we're going to do, flip a coin. Heads, we do this. Tails, we do that. Even my daughter, she has a movie wheel, because she can't ever decide on, you know, every Friday night she gets to watch a movie. That's the only time she gets to watch TV.
What?
Don't question my parenting. But she's got a movie wheel. And so it just keeps it so that I don't have to sit there and watch My Little Pony every Friday night. Yeah.
My Little Pony is amazing. What do you mean?
Sure. It's amazing the first 500 times. But she's got a wheel at home that has every movie on it. She spins it. It's probability right there. The likelihood that she's going to get to watch My Little Pony every single night is very, very slim, or every Friday night. These are things that you guys can do. Shh. These are things that you can do to be able to make a choice for you or simulate the action of that choice. So since this has 2 outcomes, flipping a coin is a good activity to simulate making that decision. Okay? Is it a question or a comment? Question?
Are there 2-sided
There are some dies that have more than, are you talking about like one of these where it's a die and then a die within a die? Like I know it's kind of hard to see it, but there's actually a little die inside. I mean, you could create one that has only 2 numbers on it. You can create anything that you would want. But when we're talking about, if we're talking about a number cube, it's your standard number cube. So you'll see all the time when they're talking about stuff in your like workbooks or in the notes on the test, anything like that, it'll say it's a fair die or a fair number cube or a fair coin. Fair meaning that each opportunity has the same chance to be landed on. So have you guys ever heard of, it's like weighted die? What does weighted die mean? Yeah, it's always going to be able to land on one specific side because it's weighted to land on that. So no matter how you roll it, it'll always land on a 5.
Basically a rigged die.
It's a rigged, yeah. So that's why when they're talking about probability, they're talking about it being a fair activity. Fair meaning that every one of the outcomes that's listed there has the exact same chance of being landed on as the other outcomes on there. So when they're talking about a number cube, you're always going to assume it's a 1 through 6. Okay? When they're talking about a coin, you're always going to assume it's a heads or a tails. Okay? When they talk about a spinner, you got to look at what options they're giving to you, but it's always assumed that each of those options has an equal opportunity, okay, so that they're equal sized. Okay, so if it's a 4-section spinner, each spinner is 25%. If it's a 3-section spinner, each one of them is 33%, okay? All right, so all you're doing with simulations is you're trying to figure out, based off of what they're telling you, how many outcomes or choices are they giving you? And how can you relate that back to one of our typical probability activities of a coin, a die, a spinner, or a combination of those, okay? So let's say that we have four random flavors of ice cream. And we want to administer that to 200 students. Can choose from. So we've got 200 students in the cafeteria. There's 4 flavors of ice cream that they can choose from. So here we're given 2 different numbers. We're given the number 4 and we're given the number 200. Both of those numbers represent something. Which one of those numbers represents a number of outcomes? 4, right? Outcomes meaning choices. So we have 4 choices. Okay, maybe you got vanilla, chocolate, strawberry, and mint chocolate chip, who knows? Okay, so right here, these 4 random flavors of ice cream, those are representing your 4 outcomes. So if we know we have 4 outcomes, typically what we go with, a spinner. A 4-section spinner. And you're going to want to identify how many sections are there. So we'll say it's a 4-section spinner. Now, 200 students can choose from. That also is a very important number. Who thinks they can tell me what that would represent if we're talking about a probability situation? What do you think, Vincent? Say it louder. Very important to know that that is trials. Vincent, what house are you again? Ravenclaw? You say that with such strong
Confusion.
Yeah. All right. 15 points for Ravenclaw. All right, so the 200 is going to represent the trials. And remember, trials means how many times you're going to perform that experiment. So we know that there's 4 flavors of ice cream to choose from. It's going to be chosen 200 times because there's 200 students that are making those choices. Okay? So if we were performing an experiment, we would have to spin that 4-section spinner 200 times to simulate the action of 200 students going through and choosing an ice cream. Now, is it going to be exact? If I land on, vanilla 50 times, does that mean and guarantee that there's 50 students that are going to choose vanilla? No. It's just a simulation. Okay? Probability is just it's an estimate. Okay? It's never an exact. So theoretically, maybe vanilla will be chosen 50 times out of the 200. Experimentally, what actually does happen might be a little bit different. Okay? Now, let's go ahead and talk real quickly about what kind of activities you should be identifying based off of the outcomes that are given to you. So we've already said it before. If there's 2 outcomes, what activity should we always go with? A coin, right? If we know there's 2 activities, automatically we should be assuming there's a coin involved. If there are 3 or 4 or 5 activities, or outcomes, then we should go with what? A spinner. Okay, a 3-section spinner, a 4-section spinner, a 5-section spinner. Okay, so we should go with spinner. And if there happens to be 6 outcomes, we go with what? A die. Okay, now sometimes there might be more than that. Let's say there happens to be, if there's like 8 outcomes, then we might have to create a compound simulation. A compound simulation. So what 2 activities could we pair together to create 8 outcomes? Brent?
A die and a coin.
Nope, that would create 12 outcomes because remember compound, what operation do we do with compound probability? Somebody said it. You multiply. So remember, when you're pairing 2 activities together, you're multiplying those outcomes together. So what would we have to multiply to get 8? 2 times what? 4. 2 times 4 would give us the 8 outcomes. So you would use a coin and a 4-section spinner. Because the coin, which has 2 sides, times the 4-section spinner, which is 4 sides, would equal 8 outcomes. If you had like 9 outcomes, you could do 2 3-section spinners, because 3 times 3 is 9. So I'll even write that down. Okay, if we have 9 outcomes, we'll do a 3-section spinner, and a 3-section spinner. Because again, 3 times 3 is going to give you 9. Okay, I think I have enough space to be able to make one little problem down here for you guys to try. So we have a woman that's pregnant with triplets. Got a woman who's pregnant with triplets. What simulation represents the genders? Woman's pregnant with triplets. What simulation would represent the genders? It's okay, sweetie. If you have to get tissues, it's fine. Just make sure you sanitize your hand after you blow your nose. All right, what simulation are we going to use? Not a spinner. Jimmy? A coin. But more importantly, how many times are we going to flip that coin? 3 times. That's important that you make that identification. There are 2 choices, right? It's either going to be a boy or it's going to be a girl. So since you have 2 genders, you have 2 outcomes. That's the coin. But because there's 3 babies, that's 3 trials. So you have to flip the coin 3 times. Let's go ahead and write that down. 2 genders represents the 2 outcomes. So that means we're going to be using a coin. Three babies, 3 trials. So essentially, if you wanted to write it off to the side, you're going to flip a coin 3 times. Any questions? All right, so I'm going to go ahead and give you guys your assignment. It's out of the workbook pages, so I've already printed them for you, and you're going to do all of it, okay? Part of it is those tree diagrams and the compound events, and the other part is just a small portion that's going to be on simulations, okay?